All right, let's dive in. We're going to talk about a medical technology that honestly sounds like it's straight out of science fiction, but it is very, very real. It's the idea of creating a virtual living copy of you. This digital twin is set to completely change medicine, and it all starts with this one powerful thought. I mean, just let that sink in for a second. That single idea really captures the incredible power we're talking about here. This isn't just about crunching data or making some predictions. No, this is about creating the perfect test subject, a digital version of you, so we can figure out if treatments are safe and effective before they ever even get near your actual body. It's a truly stunning leap for medical AI. So what even is this technology? How in the world do scientists go about creating a virtual replica of a living, breathing person? Let's break it down. And the detail here, that's the whole ballgame. This isn't some static 3D model. A digital twin is a dynamic, lifelike simulation. It models everything from your heart and your lungs all the way down to your individual genes. But its most important job is predicting reactions. It lets doctors test different therapies on your digital self first, with absolutely zero risk. Okay, I know this probably sounds impossibly complicated, right? But the process for creating your digital twin is actually pretty logical when you lay it all out. So let's walk through how we get from raw biological data to a full-blown predictive diagnosis. It really all boils down to these three steps. First, they collect a massive amount of data about your unique biology. Then, some really powerful AI algorithms get to work, using that data to build a complete virtual model of you. And finally, and this is the magic part, doctors can run simulations. They can test different drugs and treatments on your virtual twin to see what's going to work best for the real you. Now, the engines making all this possible are two super advanced fields. You've got machine learning, which acts kind of like a detective, sifting through all your health data to find hidden patterns that it uses to build that virtual model. And then there's bioinformatics, which is like the ultimate translator, making sense of incredibly complex biological stuff, like your entire genetic code. It's that combination, the pattern finding and the translation, that really brings your digital self to life. So let's be clear, this is not just some cool idea for 20 years from now. Digital twins are being used right now to tackle some of the biggest challenges in medicine today. For example, researchers are already building digital twins of hearts to see exactly how a disease will progress in a specific patient. That lets them step in before it's too late. They're simulating cancer growth to see how a tumor will react to different kinds of chemo, which could save a person from going through rounds of brutal, ineffective treatments. And, get this, they're even using this technology to study the fundamental process of aging itself. Wow. And just so we're all on the same page, this isn't happening in some secret underground lab. This work is being done as we speak at major, credible research centers all across Europe and the United States. The future is already here, it's just not everywhere yet. So what's the ultimate goal here? What's the end game for this technology? What's the grand vision that's driving all this research and all this money? Well, the ultimate promise is to finally move past one-size-fits-all medicine. Think about it. Instead of treatments that just work for the average person, we could have therapies designed specifically and perfectly for you. Every single pill, every diet plan, every lifestyle choice, all of it could be optimized for your unique biology. But, and there's always a but, with this incredible life-saving potential comes a profound new risk. As the experts are warning, creating such a detailed and valuable digital copy of ourselves, well, it opens up a whole new can of worms when it comes to vulnerability. And this really gets us to the core trade-off, doesn't it? On one hand, you have the unbelievable power of a technology that could literally save your life. But on the other hand, the price we might have to pay is that our most personal, intimate biological data, our digital self, becomes an incredibly valuable and therefore incredibly vulnerable asset. So that leaves us with this final, really critical question. The promise of a longer, healthier life, tailored perfectly to you, it's almost within reach. But as this technology grows, we're all going to have to ask ourselves, what are we willing to give up in return for it?